Hello, and welcome to the presentation. This project is a series of experiments, exploring generative design in garment creation. These experiments search for new ways that digital design and manufacture could change the life cycle of our clothes, and led to the development of No-So-Mo, the no-sew modular clothing concept, creating innovative, sustainable, repairable and interchangeable clothing garments. The process uses experimental techniques for 3D printing directly onto fabrics and provides opportunities for generative design. Currently, I've created a workflow to help other designers work with the No-So-Mo system. Additionally, I've created a proof of concept garment and a more exciting futuristic concept garment that shows what's possible with this system. This presentation follows the design journey, the outcomes, and the continuing development of this project. I'm going to talk about the context, my design process, the specification, and the outcome. And then I'll talk about the future direction. First, I'm going to talk you through the proof of concept and the futuristic outcome. This t-shirt serves as a proof of concept. I've used some of the tools that I created to break down a commonly available t-shirt pattern into a series of individual panels. Each one of these panels represents an envelope for generative design. Each panel itself can be interconnected with any other through a unique system of pipes and clips. What this means is that although every garment may have an initial set of instructions, like a Lego kit, they are endlessly rearrangeable into anything the user can think of. Next, the future concept. This jacket was partially inspired by beetle shells. What I wanted to explore with this concept was the interplay between inner and outer layers. It features an inner jersey layer and an outer mesh layer, separated by a generatively designed lattice structure which provides airflow in the summer months and can be filled with insulation to provide warmth in the winter months. Next, I'll talk about the context of this project. We're living through the fourth industrial revolution. This is a time when digital and physical technologies combine. See the birth of bioware, distributed manufacturing, mass customization, and rapid prototyping. In the wake of the climate crisis, it's evident that the current fashion system is unsustainable. In the UK alone, households sent over 300,000 tonnes of fabric waste to landfill every year. Compare this to just 50 years ago, it was commonplace to repair, to hand down, and to alter clothes. Now I'm going to take you through the design process and the journey of this project. When I started, I didn't have a brief as such, but continuing from a previous project of mine, Wear the Rain, which had begun to explore direct 3D printing onto fabric, my experimental process in this project was based on one from the RCA, in which a series of divergent experiments are carried out, each of which aims to collect data. This data is then fed to a collective data pool, and the cumulative knowledge from this is used to formulate a final outcome. I began by exploring a range of samples available online. What was interesting to me was how these 3D printed materials could replicate the expression of fabrics. I began by printing these samples exactly as I found them, and as the project went on, I experimented with altering them. For some, this was simply altering the scale. For others, I introduced new elements, and for some, I recreated them parametrically. These experiments split into three divergent directions: chainmails, monostructures. Finally, plastic textile hybrids, which I'd begun exploring in my earlier projects. In this case, plastic is printed directly onto a pre-existing fabric, offering a balance between the softness and malleability of the fabric and the dimensional control of the plastics. These outcomes provide something that is somewhere between a monostructure and a chainmail. Individual plastic elements give the overall material its character, but they are linked together by the monostructured fabric underneath. At this stage, I began to experiment using the shape of a shirt sleeve as a sort of container for my material samples. What this allowed me to do was to begin exploring the way that the shape of pattern pieces could influence both my design and the processes I was using to create those, limited of course to the size of a conventional desktop print bed. This piece is my final successful output from a rather long process of trying to generatively design a mappable mesostructure. That is one where the individual cells would be reshaped in order to better fit into the overall pattern shape. As you can see here, this one is mapped into the shape of a shirt sleeve, something like this. My conversations with other designers led me to believe that although the 3D printed textiles themselves were interesting concepts, it was difficult to see them in place of real clothing. This furthered my interest in the hybrid structures. What you see here are a collection of grasshopper generated structures applied as hybrids. They could offer a compromise between the comfort and usability of natural textiles and the freedom for creation present in 3D printed materials. My reflections on phase 1 were that it had become necessary to look into connecting multiple parts to make larger pieces, to further explore three-dimensionality, and to focus my work around plastic textile hybrids. My brief for this project was in 2 parts. 1, to produce a workflow for generative design in fashion, and 2, to produce a concept garment to demonstrate this. Starting the second phase, my focus moved on to refining the method, carried out a number of experiments, adjusting print settings and learning G-code in order to create a suite of settings which would enable me to print effectively onto both sides of a piece of fabric. At this stage, I explored a number of methods for fixing panels. I drew inspiration from closures and semi-permanent fixings I found around me. There were successes in the development of a pipe and clip. Through many iterations of both shape and tolerance, clips were developed which were both secure and easy to fit and remove. The pipe clip method is a versatile means of fixing which does not limit users to a proprietary location or orientation of the interface elements. This means that users are always able to reinvent, redefine and reimagine the way that the clips might connect with one another and individual panels. The real sustainability benefit of this project is intercepting textile waste at the point of source and then remanufacturing that waste into innovative new garments locally via distributed manufacture. These garments, once they've been enjoyed by users, can be reconfigured endlessly into new and interesting combinations to prevent them from reaching the landfill again. Traditionally manufactured textiles are in fact only 2.5 dimensional. Although they have a texture, there is no freedom to create geometry in the third direction. Instead, form must be achieved by cutting and stitching planar 2D shapes. Here, my concept of enveloping began to evolve. What I was looking to do was create a space where that 3D freedom offered by digital design and 3D printing could be explored by the designer. And I realised pretty quickly that that space needed some boundaries in order to be meaningful and especially to make sense with the rest of the space around it and the human wearer that would have eventually come to use it. CLO and Illustrator, along with other softwares, mean it's now commonplace for designers to have at least some aspect of their work digitised. This transition into the digital space means that there are new opportunities with software intercompatibility and common file type to explore much more adventurous design solutions and design tools. What you can see with 3D fashion design softwares such as CLO 3D is that we're beginning to move into a space where the work of translating a 3D mental image into a 2D pattern is actually becoming done by computers. These softwares open the doors for many types of creative digital design to break away from the traditional 2D pattern cutting table and begin to create garments almost exclusively in a 3D space. Part of my aim for this project was to bring generative design into this process. As an example, I have been using Grasshopper, a generative design plugin for Rhino 3D. This software allows the user to write simplified code called a definition, which takes external or user-specified inputs and performs a number of operations to generate complex 3D geometry from relatively simple inputs. One of the first tools that I created was the splitter. This tool creates a pipeline for bringing in 2D pattern pieces from Illustrator, splitting them into the correct size for 3D printing, and then exploring them using generative design. Here, the splitter is taking input from another tool I created, which simply provides ready-to-go t-shirt pattern pieces directly into Grasshopper. The inputs to the tool are the input curves themselves, the dimensions of the printer, and the border separation and desired output separation. And what you can see here is the output pieces themselves. Inside the tool, we receive the inputs and then calculate X and Y envelopes. We then calculate the dimensions of each of the input pieces via a bounding box, calculate the distribution for the input pieces, relocate the pieces to the origin, and calculate the number of output pieces in each direction. We will now generate a rectangular grid around each of the pieces before intersecting the grid and input pieces to get each of our individual output pieces. Next, we will separate these pieces in the X direction and then separate in the Y direction before finally outputting the pieces. What you see here are a selection of different explorations using individual output panels from the splitter. I had always aimed to produce wearable garments. This led my exploration and meant that over the course of the project I explored the use of many different fabrics. What came to light was a number of key variables which influence the success of the fabric being used and how easy it is to ensure an adequate bond between the print and the fabric itself. The crucial factors here are the thickness of the fabric, its composition, the closeness of its weave, and its resistance to heat. One of the crucial factors in successful printing onto fabric was my exploration of G-code. The G-code I've implemented allowed me to pause, adjust the temperature, adjust the fan speed, and adjust the Z offset, all during the print process. I investigated many methods of fixing fabrics to the build plate. In the end, it was settled on using magnets, since this allowed inboard fixing rather than just around the outside of the geometry. The final outcome is a workflow modelled on my own to help other users create panels within the system. This workflow consists of 4 parts. Concepting would be carried out in the traditional manner using draping, sketching, and fabric samples, for example. After the users have come up with a concept, they would then move on to the enveloping phase. In this part, tools I've created are used to generate a 3D space representing the final garment. This space is then free to be explored using generative and innovative digital design techniques. The envelopes can be created from 2D or 3D patterns or space claims. For example, a model of a human body might be used to provide an inner surface. In my own workflow, I've used 2D patterns for t-shirts and jackets, which are commonly available through the internet, then modified using Adobe Illustrator before being imported into Rhino 3D. Next, the innovative design stage. In this part, users use tools that I and others have created to explore their 3D envelopes and create new and interesting geometries and textures. In this part of the process, I have created tools for creating 3D bubble and mountain geometries, as well as representations of buildings and various different wireframes which can be used as textures. Additionally, I've developed a tool for automatically generating the 3D pipe and clip structures. These structures will be used to fix panels together in the final outcome. Finally, the digital manufacture stage. Here, laser cutters, 3D printers and digital embroiderers, as well as other machines, allow users to realise their designs more quickly and without the need for giant factories from the comfort of their own homes and studios. Additionally, these techniques provide opportunities for rapid development of garments that would take months without them. And further, the techniques themselves can produce some outputs, such as self-linking chainmail, which are not possible using any other technique. In this stage, I have produced a suite of settings, as well as instructions for 3D printing directly onto fabrics. As you can see from the bill of materials, the cost of making a t-shirt is approximately £8, with the bulk of this being the TPU filament. This filament, as well as being expensive, is also unsustainable. It cannot be recycled and is environmentally damaging to produce. Consequently, further development will look to move away from this filament. The costings for producing a commercially available t-shirt, generatively sized to the individual, and with uniquely generated surface textures and geometry, is approximately £60. Whilst this may seem expensive for an individual piece of clothing, in the luxury market this is well within the viable cost. Further, another application could be the development of haute couture garments. This cost of approximately £9,100, although very expensive, is again very viable. The average cost of a haute couture garment to the customer starts at £17,000 and can go up into the hundreds of thousands. The continued development of this project will be principally collaboration. I'm looking to work with an experienced fashion designer, as well as someone who is more experienced in coding. The help of these two will enable me to produce more radical garment designs, as well as to continue to develop the toolkit and workflow. To further this development, I am planning to increase my print capacity by building a custom, large-scale 3D printer specifically designed for printing onto fabrics. I think it's important that I develop some more successful and glamorous clothing samples to show off this concept. The coming months will see an exploration of funding options, from master's courses to Arts Council grants. In conclusion, this project has been a steep learning curve. I've learned a lot about 3D printing, and I believe that in just this short time I have entered some interesting new territory. I'm excited to continue my work in this project, and I think that with some more time this will present an interesting direction for other fashion designers to consider. I hope you've enjoyed this presentation. I have not had time to cover all this project in much depth, but I hope that it's piqued your interest and that you would like to find out more. You can keep up with everything on Instagram @muglife,